Hello. So I hope you're ready to start Unit 3 because that's what we're going to be doing today. Our first topic in Unit 3 is complex numbers. So the first thing you need to know about complex numbers is standard form for complex numbers. So anytime we talk about standard form, we want the number written a plus b I, meaning we have the I term separate from any other terms we might have. Okay, so what makes up a complex number is any type of real term as well as what we call an imaginary term, right? Or a term containing our imaginary unit. Our imaginary unit we call I, and we have defined I to be the same thing as the square root of a negative number, okay? The square root of -1. Because notice when we're doing stuff, I'm just going to put this little example over here. If we're trying to do something like the square root of -25, right? We're looking for a number times itself that would give us -25, and it doesn't exist, right? Because we would think maybe 5, well, +5 times +5 gives me +25. And then we think, well, maybe -5, right? But -5 times -5 also gives me a +25. So there's no number times itself that will give me a negative under a square root. So what we're going to do is we're going to think about writing this and saying this is the same thing as -1 times 25, right? And the reason we can separate that is because it's just being multiplied. And we have a rule with our radicals that we can multiply radicals as long as they have the same root, meaning we can use that property backwards, and I could write this as the square root of -1 times the square root of 25. Okay, and then the square root of 25 we can simplify. This is just 5, but we don't have a way to define the square root of a negative number. So that's where I comes in. We are saying that I is the same thing as the square root of -1. Okay, so that way we can simplify something like the square root of -25. We would just get 5i. Okay, so anytime you see a negative under a square root, you can think about just pulling that negative out as an I. Okay, and that's what we want to do anytime we're dealing with negatives under radicals. We want to make sure we pull that negative out as an I. Okay, now what's neat about I equaling the square root of -1 is that if we were to square this I, okay, so think about squaring both sides. I squared equals the square root of -1 squared. When I square a square root, those things just cancel, right? So that's where we get this. I squared is equal to -1. So what that tells me is that we should never have a higher power of I in our answer than the first power. Because if we end up with an I squared, we can replace it with -1, right? Even if we have something like I cubed, we could write that as I squared times I. Okay, so there's no reason to ever have a higher power of I than just the first power in your answer. Okay, so that's going to be my little note here. Let me erase this line so that I can write it here. You should only have an I to the first power in your solution. Okay, you should only have an I to the first power in your solution. Okay, if you have anything higher than I to the first power, then you need to do some simplifying. Okay, so let's look at performing operations with complex numbers. So you can see this is a complex number. That's why it has parentheses around it. -7 plus 6i, that's a complex number. 5 minus 4i, that's a complex number. So these parentheses are just signifying that that is a complex number, okay? Doesn't mean we have to keep the parentheses, right? Unless there's something being done outside of it, which in this case, nothing's being done outside these parentheses, so I can just drop it and combine like terms. So this is just -7 plus 6i plus 5 minus 4i. And then we combine like terms. So we combine our number parts, right? -7 and 5 gives me a -2. And then we combine our I parts. So 6i minus 4i leaves me with a +2i. And we just leave it like that. Not too bad, right? All right, so let's look at subtracting. Subtracting, before we can just drop our parentheses, we do need to go ahead and apply this negative, right? We have to subtract the negative, just like when we were subtracting regular polynomials. When we subtract or distribute that -1, it's going to change these signs, right? So I already have the I, and I already have the +3. I'm sorry, I already have the 1, and I have the +3i. Then when I distribute this, it's going to change these signs. Now again, you can write this all out as one long stream of terms, or you can stack them. It's up to you. I'm going to go ahead and stack them. All right, so when I distribute this negative, that is going to give me a +4, right, and a -8i. So I'm going to just go ahead and line up my I terms and line up my regular terms. And now I can just combine like terms really easily. So I end up with 5 minus 5i. So I'm going to go ahead and circle that, and I just leave it like that. Not too bad, right? So I want to look at multiplying complex numbers. Multiplying complex numbers is very similar to distributing polynomials, right? The FOIL method, things like that. But I do want to go ahead and show you just so that you get used to it. Now, sometimes Knewton will put the little multiplication dot in there rather than just put the parentheses right up against each other. It means the same thing. You're still just multiplying, okay? So we're going to multiply the first term of this polynomial times the first term of this. Or in other words, our constant term and our complex number times this constant term. So when I do -5 times 1, I get -5. When I do -5 times 7i, I'm going to get a +35i. Okay? And then I need to distribute my 2i. So I do 2i times 1 is a +2i, so I can line that up with my other I term. And then +2i times -7i gives me a -14i squared. So I'm going to go ahead and combine my like terms. So I have -5 plus 37i minus 14i squared. Okay, so seemingly we're done. This is how we would multiply polynomials, except we don't have polynomial. Well, we do have polynomials, but we have an I squared, right? Remember, I squared can be simplified because I squared is equal to -1, right? So never leave an I squared in your answer. Always replace it with a -1. So I have -5 plus 37i squared, and then minus 14 times -1. Now, when I multiply this -14 times -1, that's going to make it a +14, right? So I'm going to go ahead and just mark that out and put plus 14 over here, because now I can combine it with my other number digit over here. So 14 minus 5 leaves me with a 9 plus 37i. Oh, I don't know why I have an I squared written here. I'm sorry. 37i. Okay? And then we just leave it like that. So make sure you do not leave an I squared in your answer. You should only ever have the first power of I. Okay? Let's look at another one. I know this one says to add, but I want to get another example of multiplying. So let's change this to a dot. Pretend this is a dot, and we're going to go ahead and multiply this one. Okay? So I'm going to do 9 times 2. 9 times 2 is 18. 9 times 6i, when I distribute here, I'm going to get positive 54i. And then I need to distribute my second term. So negative I times 2 gives me negative 2i, and I'm going to line that up with my other I term. And then negative I times 6i gives me negative 6i squared. Okay, so again, I'm going to go ahead and combine my like terms. So I have 18 plus 52i minus 6i squared. And then remember, we want to replace I squared with -1, right? So if I do -6 times -1, that's going to make it a +6, right? Plus 6. And now I can go ahead and combine this plus 6 and my 18. So 18 plus 6 gives me 24 plus the 52i that I have in that second term. Okay, everybody kind of okay? All right, so on the next page, there's 2 for you to try. So go ahead and pause the video so that you can work on these practice problems. Once you have done those and you're ready to check yourself, or if you get stuck, go ahead and play the video and check your answers. Okay? All right, so on number 1, all you had to do was distribute this negative sign, which is going to change the signs of your second two terms. So it makes it a negative 20 and a positive 4i. And then we're just combining our number terms and our I terms. So we end up with negative 9 minus 2i. Okay, let's go ahead and look at the second one. The second one was a multiplication. So on our multiplication, when we distribute our I keep saying I for 1. Bleh. When we distribute our 1 to the first quantity, we get negative 4 and plus 10i. And then when we distribute our 3i to both terms, you should get negative 12i plus 30i squared. Okay, so we want to go ahead and combine straight down. So we have negative 4 minus 2i, and then I went ahead and put in my negative 1 for my I squared so that I can go ahead and combine that. When I do 30 times the negative 1 I get from the I squared, that's going to make it a negative 30. And then I can combine that negative 30 with my negative 4 out front, which gives me negative 34 plus 2i. Okay? All right, so this was a pretty short section. So you should now be able to do the homework assignment in Knewton that is called complex numbers. So if you have any questions, please let me know. Otherwise, good luck.